Let us try to understand how to graph the rate of change of the functions. The question is, describe and sketch the rate of change of each of the following functions. We have two functions here. The first one looks like an exponential function. The other one is a cube root function. Now, let's analyze them first and then see how can we sketch the rate of change of the given function. Now, in this particular function, it seems that if we have a very large negative x value, that means if we are on this side of the graph, then a tangent to the graph will be kind of horizontal. That means the rate of change is 0 as the x value is higher. So it is approaching 0, right? Slightly positive here. All throughout we see that the tangent at any point will be positive. So we know one thing, that as x approaches infinity, minus side, so as x approaches negative infinity, we see rate of change, which is delta y over delta x, approaches 0, right? So it approaches a horizontal line. So it is approaching 0, that is first part. Now as we move forward, that means towards increasing values of x, we see that the slope of the tangent becomes more and more positive. Do you see that? It becomes more and more positive, right? So as the value increases, becomes more and more positive. Now, what we can draw here, as we know, the graph will be kind of like this, right? And it is going to be more and more positive as we move forward. So as we go, as the x value increases, it increases faster, right? That is the reason why we have a slope which is not constant, but which is increasing with the increasing values of x. Correct? So as x approaches towards higher values, that means towards plus infinity, this value delta y over delta x actually becomes infinitely large. You see, so that indicates infinitely large. And slope is kind of increasing faster as we move towards the right, and that is the reason why we have a curve which is moving upwards. So that is kind of the graph which we are going to get for rate of change of this particular function, right? Now to get the values on this graph, what you need to do is find slope of your tangents, right? So for example, this slope looks like half, right? At this point, looks like half. So I have a value which is approximately half. At this point, it looks like 1 to me. So I have a value maybe slightly higher. We have a value which is slightly more than 1 kind of, right? So that is how we have got the curve. So exact values you can get by making the tangents at each point, right? So I'm saying exact values, but these are all estimated, approximate values, since the graphical solutions are never exact. Okay, so we can get close by values. So this graph which I've shown here is a good representation of rate of change for the given function. Now let's analyze the next function, which looks like a cube root function. The function is probably f of x equals to cube root of x. It has domain of all real numbers, and the range is also all real numbers. It is important to note that at origin it is kind of a straight line, right? So if it is a straight line at the origin, then the rate of change here is undefined, because rise over run, correct? So at this point, delta y over delta x is almost 0. So anything divided by 0 is kind of infinity, is not defined. So we can draw a vertical asymptote at this point. Now as we move further away from origin, what we see is that the rate of change is actually the slope of the tangent on the graph. So we find that the slope is always positive. Do you see that? Slope is always positive. In the left half in quadrant 3, the slope is positive, lower value for higher values of x, right? So it's lower values here, but as we move further, it really increases, kind of. Do you see that? It kind of increases, increasing infinitely large as we approach 0. So that seems to be the rate of change for this particular function on the left side. On the right side, again we see the same thing. It is high positive value going on to almost 0 as the function is tapering down to some, right? It is increasing, but increasing at a much slower rate as x value increases. So on the right side, it is kind of like this. Do you see that? So that becomes the graph or rate of change for this given function. From the symmetry, this graph should also be symmetrical, right? So I hope that helps you to understand how to sketch rate of change for a given function. Thank you.